Very good morning, students. I am Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are discussing the subject called Engineering Mechanics, the subject code ME25C02 under the regulation of 2025, coming under the semester of 2. Second semester, the students are studying this subject. So far, we completed first 2 units, that is statics of particles, statics, statics of rigid bodies. Then moment of inertia we have started, and we successfully completed the first 2 parts in a successfully manner in our previous lecture videos. Today we are going to see the continuation topic of that. What are the topics you have left out in the unit 3? We are going to see one by one. Now we are going to see the topics in the upcoming slides. So this polar moment inertia, actually in our last video, I have given some definition about that polar moment. We touched that topic but in this I am going to give some formulas based on that, and if time permits you will solve some problems based on this polar moment of inertia as well as followed by some other topics also. Now what is polar moment of inertia means? The polar moment of inertia of an area A with respect to pole O is defined as Jo equal to integral of r square dA. The distance from O to the element of dA is r, observing that r square is equal to x square plus y square. Therefore, the relationship you will get Jo equal to Ix plus Iy. Here, you must know that this is the equation already we have used. That is r square equal to x square plus y square. We have used in the previous session also. The same thing, the equation we are using. Now, this is one elementary strip, that is a cross section of dA under the distance of x in the x-axis and the y along the y-axis, having some hypotenuse distance, that is r, from away from that distance, that is along one direction coordinate it is given. Now, based on that previous definition and formula, we are going to solve one problem based on this. So, determine the moment of inertia about centroidal axis and compute polar moment of inertia, radii of gyration of plane area as shown in figure. This is one Z type of one channel that is given, various section that is given. We have to divide it into various section 1, 2 and 3. Take the origin as shown in the figure and divide them into various rectangles. You can see the various, we can form some rectangles. Here you can see in the right hand side of the slide, we can see one of the rectangle, that is 1 named as 1, have a cross section, and the 2 is also named over there. Then finally 3 is also named over there. We have the different cross sectional areas we are having. Now, based on that previous sketch, we have the tabulation form. In this type of problem, we should follow a tabulation. In this, the first column is meant for what are the section we are divided, that you have to put in 1, 2 and 3. Then area, based on the values, cross-sectional areas, what is the length and breadth, what is given, you have to multiply and you have to get the answer. 200 into 40 and 30 into 140, 100 into 20. And along x, what is the value means 100, 15 and minus 20. So based on the values, you have to get the centroid of that one, and y also we have to get the centroid. Then finally we have to apply the moment of inertia along x and y axis formula, that is bdq by 12. Another one is dbq by 12, that is vice versa of that one. So we have to multiply bdq by 12 divided by, we will get the final answer. Here it is mentioned. The next slide we will see the values. And what is that x minus x bar means? We have to find the x bar separately. What it is, what you covered in the unit 1, sorry, part 1 of this unit 3. We have completed up to some centroid. We know how to find out the centroid x bar and y bar. The same procedure again you have to use. We will see in the upcoming slide how you got the x bar and y bar. These are the values that is highlighted over here, 42.04 and followed by minus 42.96, and here also y minus y bar, that also in mm we have the values minus 50.56, 39.44, 119.44. So this is the calculation how we are getting here. This we have mentioned here. So area, we know that summation of all areas you have to add up. Then what you have to do, that particular AX divided by the total area. Then you will get 57.96. That is the value we have put in the previous slide. That minus x minus this one, like that. Then y bar equal to, we are getting 70.56 mm also we will get. Then apart from this, now you are going to the moment of inertia. Now how to find out moment of inertia? Now how to find out Ix plus A, y minus y bar, the whole square. Then followed by, we have to apply the formulas. 200 into 40 cube by 12, then 200 into 40 into minus 50.56 the whole square, then plus the remaining value also we have to put 30 into 140 cube by 12. Then along with that we have to put 30 into 140 into 39.49 square, plus 100 into 100 into 20 cube by 12, plus 100 into 20 into 119.44 square. Then you will get Ixx is equal to 63.509 into 10 to the power 6 mm power 4. Then followed by Iyy equal to summation of Iy plus A x minus x bar the whole square. You will get these values. Then finally substitute the values in the expression. 40 into 200 cube by 12 plus 40 into 200 into 4.42.04 the whole square, plus 140 into 30 cube by 12 plus 140 into 30 into minus 42.96 the whole square, plus 20 into 100 cube by 12 plus 200 into 100 minus 77.96 the whole square. The finally you will get 62.694 into 10 to the power 6 mm power 4. The unit of moment of inertia is millimeter power 4. Here we can see these are the calculations we are having. X minus x bar, that value you are having, just you have to apply in the formula and finally you will get the answers. Now polar moment, our main aim to find the polar moment of inertia. How we are finding the polar moment of inertia? Just we are applying the formulas. How we will apply the formulas? Iz equal to Ixx plus Iy. This is simple calculation. What are the values you are getting in Ixx and Iyy? Simply you have to add these two values. You will get the final answer. Now what is the final answer? You will get 126.203 into 10 to the power 6 millimeter power 4. And kxx is equal to root of Ixx divided by sigma A. Therefore, you will get 66.88 mm, that is kxx. That is kxx is nothing but radius of gyration along x-axis. Kyy is nothing but radius of gyration along y-axis. Kyy. Then z also the same thing. Now Iyy divided by sigma A. You will get these values, 66.45. And finally, you will get 94.27 for KZZ. Therefore, 126.203 into 10 to the power 6 divided by 14,200. Now you will get 94.27 mm. Then find the moment of inertia of the T section shown in figure about its centroidal axis. This is the T section. 1, 2. We have the two sections. The previous problem we have seen so many sections for this diagram. In this we have only 2. Very simple one, only the same thing. Area we have to find first, then followed by y, then Ix, Iy, then finally y minus y bar. We have to find that y bar also. Now the same step again it should be followed. So it is a symmetric only. There is no need to find for I bar separately. Already we will get the answer directly. We can use that value, whatever it may be, because it is symmetrical about x-axis. Therefore, y we can directly write the value. So upon this, we have the calculation. Sigma A equal to 15,000. Therefore, mm square. Ay 1875000 mm cube. Then y bar you will get 125 mm. Similar formula we have used in the previous slide also. Ixs is equal to summation of Ix plus A, y minus y bar the whole square. Just you have to apply the values 150 into 50 cube by 12 plus 150 into 50 into 50 square plus 150 into 150 cube by 12 plus 50 into 150 into minus 50 square. You will get 53.125 into 10 to the power 6 mm per 4. Then Iyy equal to 150 into 50 into 150 cube by 12 plus 150 into 50 cube by 12. Finally, you will get a 15.625 into 10 to the power 6 millimeter power 4. So these are the two references which I used for preparing this content. So kindly go through these references. So students, thank you all of you for your kind attention for listening this lecture video. Kindly subscribe this channel and share this video to your friends. So we will meet in the upcoming videos, that is part 4 of this unit 3. Thank you students.